All right, I'm not sure I'm going to be able to find a picture of what this was historically, because I'm not going to spend more than 45 seconds looking for it. Well, that's an idea. What it is, it's programmable. We tell it to go forward, right, turn left, turn right, to back up, or to draw a circle. Those are the easiest commands. Those are the ones we'll play with. So you can tell it to make angles, you can tell it to draw lines, you can also tell it to pick up its pins so that it can move around on the screen without.
It's called a turtle what?
Yep, turtle. We're just going to call it a turtle. We're going to use something called the turtle library, which will support it. Let's see, one more try. That's what it looked like originally. Not much of a turtle, right? But it was programmable. Kind of looks like those, you know, the most recent Star Wars, the BB robots. You know, you could buy a little model. I mean, you know, buy one and it'll roll around on you. But anyways, it was designed to teach kids programming. One way to do that. And so you had a computer hooked up to it. You could tell it to go forward. You could tell it to turn a specific angle, draw a line, draw a circle, and it would do all that stuff. Of course, we're not going to control a robot, although it'd be pretty awesome. Instead, we're going to do it with programming on screen. So the very first thing in our code is going to be import. It's going to say import turtle because turtles aren't built into Python, right? You know, the Python language doesn't need a million things built in, but it ships with the turtle library, and we can get that functionality, just like, you know, probably have the idea of installing a plugin or installing a new module in a game or something like that. That's what we're going to do. So I'm going to pop open idle, search box, idle. If you don't feel like typing along, that's okay. We're going to do file new. Please do not type in the arrow, arrow, arrow prompt. Instead, do file new. And here's where my program's going to be. So I'm going to do a save as. And since they don't allow me to create favorites in my list, go to CIT1.
Go back real quick.
Uh-huh.
Start again.
Yep. So I started idle. And then I did file new. Because you never want to enter code at the place with the 3 cursor like that.
Okay.
So file, new file, and I'm just going to do a save as right off the bat. File, save as. I'm going to go to my favorite directory. I made mine off the desktop. I'm going to call it lecture C space turtle, because we may do another lecture C as well, right? That's not turtle based. So lecture C turtle, or whatever you want to call it. Name it by date or whatever. Okay, so as promised, import turtle. Now in this particular case, capitalization is very important on the next line. All right, I need to give the turtle a name. And Ninja Turtles or something. I don't remember all their names, but Leonardo, I'm going to call my turtle Leo. That's an L rather than a 1. Lowercase l.
You just import that turtle or the...
Yep, you type that. Import space turtle. Now Leo equals, and this is all lowercase until I tell you to do an uppercase letter, turtle dot, and then capital T, turtle, and then an open parentheses and a closed parentheses. All right, and then we're going to make him draw a circle. It's just one command to do that. Leo dot circle, all lowercase, and I want the circle to be 100 pixels, 100 pixel radius. So Leo circle, parentheses, we just started, 100 in parentheses, and that's enough to test it. Make sure it works. So I'm going to do run module, and there's our turtle running around. Of course, it looks like a little triangle instead of a turtle shape. We could actually change that icon to something else with some programming commands, but I'm not gonna. Right? Well, let's make him do something else. Maybe we'll make him turn to the right 90 degrees. And then draw another circle.
Wow.
So Leo.right, and by the way, we could abbreviate that RT if that was easier to type. The one that I really usually abbreviate is forward to FD, because if I type forward up here, then people leave off the R's or, you know, whatever. Anyways, so Leo.right, he's going to go 90-degree angle. And I'm kind of making a clover shape. It's going to have 4 circles on it. So rather than type in Leo.circle, you know, 3 more times to make him draw 4 circles, I'm going to cheat. I'm going to copy this stuff. Edit, copy, edit, paste. Of course, I usually like keyboard shortcuts. There, that's 2 circles, 3 circles, 4 circles. File save. Of course, it saves when you do run. Run module. All right.
I just have a syntax.
I'll be right there. Yep. And so he drew his kind of clover leaf looking thing. Now that's pretty slow. We're going to speed him up. Then I'll walk about, make sure everybody's doing okay. So I'm going to add a speed command. Leo.speed, parentheses, 10. That's kind of like full speed ahead. You can actually make him go faster, but this is probably going to be fast enough. It's like you can set the speed from 1, which is ultra slow, to 10, which is fast, but then if you set it equal to 0, it's like instantaneous. So maybe we'll change it to 0 in a minute. Yeah, because that's still not very fast. And we are impatient, right? So I'm going to change that to a 0, and it's going to go as fast as possible. There, boom. All right. You can kind of see why I like the speed being lower when we're actually looking at it draw. But there we go. All right. I'm going to pause the recording, do some syntax error checks. So the way I was able to calculate that is because I knew I was going to do 4 of them. And so it's 360 degrees, the whole circle. I don't care if you remember this math or not. Divided by 4 is 90. So if we wanted 3 circles rather than 4, it would be 360 divided by 3, which is 120. So maybe I'll change those to 120. It's going to draw one of the circles twice. You don't have to do this because who knows, I may undo it. I'm going to change that to a 120, 120, 120. Maybe I'll comment out the last one because I don't feel like drawing the first circle a second time. Where are you here? Get lost. All right. And so it drew our 3 overlapping circles. What if we wanted to draw a square? Well, there is no square command. We have to draw all 4 of those lines ourselves. But we can do that, right? We'll just do a little bit of cut and paste. So why don't we make him go forward? And like I said, I like to abbreviate forward just because it's easier for students to type. But if you want to use the whole word, it's fine. Leo.fd. Let's make him go 100 pixels. And then let's be novel and make him go to the left. I said left and I started typing right. Leo.left. Let's draw a triangle. So we're going to make it 120 degrees. So we're only going to have to draw 3 lines. Now copy and paste those 2 more times so that we have 3 lines. You can see that I took the spaces out because I was trying to keep the whole thing on the screen at the same time, but I'm going to stop worrying about that. In fact, I'm going to delete that comment so it's easier to do and I don't have to cram these together. I want to watch him draw it, so I'm going to change the speed back down a little bit. I changed the speed back to 10 so I could actually see him do his little jig. And it blew up. What do you know? Lee is not defined. I guess I was talking to you. Leo. There we go. My mistake. A good example. Before you use a variable, it has to be declared. If you get a variable name typed in wrong, it'll yell at you. Did I have it? Oh, did I do that like, for Pete's sake. Okay, I got a bunch of them I got to fix. That's one problem with cutting and pasting. You make one mistake and then you repeat it a bunch of times. If you typed Lee like I did, untype it. All right. It's real fast to draw triangles. Apparently it takes a lot longer to draw a circle than a triangle. And that kind of makes sense because it's got to draw a little bit and turn, a little bit and turn. And maybe if we got rid of the cursor, you can hide the cursor. Maybe it would draw faster still. All right, there's one more step that I want to do to this, or actually two more steps, but I don't want to get too far ahead of people, so I'm going to pause the recording again. If you feel like it, go ahead and change your code to draw a square rather than a rectangle, or draw a square on top of the rectangle, right? It's just going to be some more copying and pasting, but you're going to change it to 90-degree angles. All right, so that was lecture C, turtle. We're going to move on, and we're going to talk about other things. That was supposed to be the fun time, to get us used to the idea of functions. There were several function calls, right? Each time we did something with parentheses, that was a function call, but this is a function call built into the turtle class. And guys at home, I stopped the recording and forgot to start it, so if you want all the rest of the code you're seeing here, go to the daily notes and you can copy it, but you don't gotta. So we had some function calls and then we defined our own function. Every time you make a function call, it has to have parentheses after it. Does that mean you always put parentheses after it, right? If I do this, a is equal to 10, right? You don't go a is equal to 10. No, you only put the parentheses, delete that, when you're doing a function call. Now, one thing we could have done that might have been interesting is to store these things in variables. Like, what if you wanted a small triangle rather than a large one? I could have done something like this. Side is equal to, 100. And then when I was going to send him forward, Leo.side, or excuse me, Leo.forward side, like that. But then if I wanted ever to make it, and then I'd turn him right, and then I'd make him go forward again. If I ever wanted to make him draw some smaller triangles, I'd just make that 50, right? Or 10. So I could have y'all do a search and replace all these 100s with a smaller amount. I'm going to delete that line that I added up there at the top. All right. And again, guys, at home, I apologize. You might just want to go and get this from the notes right now or just watch along. We're going to open up a new document pretty soon. So if you want to do a search and replace, hit Control-H if you're on a PC. Otherwise, Command-H will probably work on your Mac. And we're going to find 100, and we're going to change it to a smaller number. We're going to draw itty-bitty things, 30. And then do replace all. No. Yeah, that would work, but I want to do it a little bit more clever.
So what is Command-H supposed to do?
It pops up this replace dialog. You better try. If it does not do that for you, then go to Edit, Replace, and I don't know what your keystroke for it is. Did it come up? Yeah.
Yes.
Okay. And we're going to replace every occurrence of the little number 100 with the word size. But we're going to have to define what size is, or else the code is broken. So I typed in 100, I typed in size, and I'm going to click replace all. Now if you look up and down in my code, you'll see everywhere I had 100 is now size. Cool. Well, that's not going to work. The code is broken because it doesn't know what that variable is. You always have to declare a variable before you can use it. Size is not defined. Well, it's going to be. So under Leo speed or something like that, size equals 50. I'm going to make the triangles and everything smaller. Whoopsie. And then I'm going to run it. All right, everything's smaller. I could change it to 10. There. Cool deal. I'm happy with it. One thing that would be cooler is if we put these things in loops, so we could draw as many circles as we wanted to, right? If we wanted to draw a shape that had 10 circles in it, then it would do the math. 360 divided by 10, it would know that it needs, every degree should be 36 degrees, and so on. So if you ever close a file and you ever want to open it again, I'm sure that some of y'all have seen this. If you go in and you double click on your file, you're never sure if it's actually going to run it or not. Now mine may be configured to edit it, but it may not. If I double click it, it may run something called WinPython. Now I don't want WinPython, you know, or it may just run the script right then and there. You might be able to right click on it and choose, well, I don't want to do edit with Python Win. If there was an open with idle, that would be pretty awesome. On your computer at home or something, there may be open with idle. In the other classroom, it says edit with idle. It doesn't say so here. So what I would need to do is I would need to launch idle again. And you don't have to be doing all this. This is just educational, right? And then I could do file open recent and get back to it. Or if it's not a recent file, I could just do open and go and find it, right? So you download the file, you double click on it, it's probably not going to let you edit it. So you'll want to try one of those two things. Right click and see if it says edit with idle. If it doesn't, then just run idle and open it from inside there. Check to see if it's in the recent files list first. Alrighty. That's enough about, now we kind of went off the rails and did our own thing. We're going to come back.
I just tried to do the Command H again and threw me out.
Yeah. I don't know what the keystroke is on the Mac. Once you figure it out, you can tell me.
So you said edit, replace.
Yep.
100, replace with size. And that's all you put in there?
You got to add one more line to it. Above everything, you got to tack this on. Above draw C, put size equals 10.
Oh, I got to do that before I edit?
Before or after you replace it, either way.
Okay. Replace all.
Yep.
Okay. Now. Leo speed. Oh,
Yeah, underneath that, do size equals 10.
Size.
Looking at me like I haven't actually done a PowerPoint yet. Surely that's not the case. Is that one? Yeah, there we go.
Okay, now running?
Sure, see if it works. If it doesn't, we'll get it fixed at the end of class. Alrighty, chapter 1. Did we start this last time? Give me a thumbs up if the PowerPoint's looking familiar. Maybe I completely blew past it. Surely I talked about this stuff. I did. All right. Okay. The program development cycle. Understand the problem. Well, I'm going to draw 3-leaf clover with turtle. Plan the logic. Code the program. Now, when I'm up here, you see me skip this stage, right? often sit there and write out the problem by hand. That doesn't mean you're not supposed to do that. It just means that I already have it fully formed in my mind. You know, and once you get experience, you may be able to sit down and write code, but if it's a big project, it's a bad idea to do that even if, you know, you've been programming 30 years. Then use software to translate the program into machine language. Test the program, put the program into production, maintain the program. Now, they're not showing a lot of stuff here. Usually what happens is you code, you test. You code a little more, you test. You code a little more, you test. Then you show it to the person you're writing it for, and they go, yeah, that's great. Or they tell you to make changes. And if you have written plans for it, you go and modify the written plans to accommodate their changes. Then you code the program and test. It's a cycle, right? You keep repeating that over and over. And if you are writing programs for somebody else, you'll find out that they never know what they want, right? They'll write down what they want it to do, and if you implement perfectly what they want it to do, you'll find out that it's not what they want it to do. It's just a fact of life. So then you go and you make some changes to the plans, and you make the changes to the code. You know, and hopefully at a certain point they're happy, or somebody in sales can tell them, no, we've done enough, something like that. Once the program has been put into production, like you've delivered it to the customer or you've published it to the App Store or something, maintain the program. That's when you get bug reports. What if somebody didn't like the fact that our three-leaf clover looked the way it was, right? When we draw a three-leaf clover, it's supposed to have some kind of circle going up to it, you know, a semicircle, a line going to it. And so they might file that as a bug report. Program doesn't draw the stem. And then, you know, if whoever collates these bug reports, you, if you're the only programmer, decides that that's a valid request, you'll go and fix it. Or they say it draws the clover too fast. I want to see the circle moving. You would know that that's a bug report. You would change it, and then it would go slowly for everybody. Maybe they hate that, and then it becomes a problem. What if one customer likes it doing one thing and one makes it do the other? And you probably know that you can make configuration screens, right? You might have a speed setting or something like that. That's pretty beyond where we are now, but you understand that. So after, that's what maintain the program means. You get bug reports, you do the same thing. Plan the logic for how to fix it, you code it, you test it, you keep doing that until it's good, and then you give them the new version. Like this. Except it's got lots of little loops in it, right? Plan the logic, write it. This is a step that we don't really do. It happens on the fly as soon as we hit run. I think I talked about interpreted programs. And you test the program. Write, test, write, test, write, test. You think it's great, so you send it to the customer. They complain. Plan the logic, write, test, write, test. Finally, it's perfect. So you put it out in production, and then you maintain it, right? But then they complain about it, and the whole thing starts over again. So one of the most difficult aspects of programming is understanding the problem. If you don't understand the problem, you can't write it. If I ask you to write a program that will convert, you know, kilometers to furlongs, some, you know, ancient English thing, you're not going to know what a furlong is. You may not have even understood the word when I said it, right? That would make it pretty difficult. What if you understood the word, but when you Googled it up, you couldn't find a conversion? You couldn't find a conversion that said kilometers to furlongs. So, you know, you got to understand the problem. You have to ask your users, if you don't understand the problem, for clarification. And then they'll finally tell you, oh, well, you know, that's an English unit of measurement, and a furlong is 300 yards. And then you go, oh, I see. I can convert kilometers to yards, and then I'll be able to get to furlongs, right? That's all the stuff that you will be doing once you understand the problem. So the end users are the people who should be telling you what they want, or if you're writing a game, right, you're telling them what they want. But these are the people for whom the program is written, and the documentation is the supporting paperwork for a program. Now we're talking not just writing 5-line little programs for a class, right? But you still have documentation. If I give you a homework assignment, that's documentation. And if I ask you to draw a flow chart for it, that's more documentation.
If I ask you to write pseudocode for it, that's more documentation. Traditionally, what you ought to be doing is writing the problem out. If I give you that problem, you don't need to write it out. Then creating the pseudocode, which is a map of how you're going to solve it, and then maybe draw the flow chart as well, and then actually do the coding. Now, what you're going to want to do is you're going to want to read it and skip straight to the programming. I will make y'all draw pseudocode and flow charts for part of the class, and then towards the end, I'll stop making you do that. And then if you run into trouble after that point because you're not understanding the problems, I may say, but have you done your pseudocode, right? May ask you to go back and do that. So planning the logic. You got to plan the steps and what they include. The algorithm is a sequence of steps or rules you follow to solve a problem. Let me go to Notepad. Problem. Convert kilometers to furlongs. I'm not even sure if I'm spelling that right. Let me get a slightly larger font. Right. There we go. We got to map out what it's going to do. Right? Things I want it to do. Ask for kilometers. Ask the user for kilometers. Convert kilometers to furlongs. I may not know how to do that. I got to go and find the formula. I'm going to write some more specific stuff. I'm going to do a begin. I forget if they call it start or not. Maybe start. What is it going to do? It's going to output how many kilometers or kilometers. Then we're going to get some input. Input from the user into kilometers. And then we're going to calculate. We still don't know what we're doing here, so then a miracle occurs. And then output furlongs. And then we're going to put a stop here, or an end command here. This is starting to look like pseudocode. Pseudocode is when it kind of looks like a programming language, but it's not. That's not a programming language. But it is a series of steps that we would follow to solve the problem. Except that's not a good one. I don't know the conversion, so I'm going to do a little bit of searching to figure out, yards to furlongs, or furlongs to yards, something like that. Turns out that 1 furlong is equal to 220 yards. Cool. So I would put that somewhere in my notes. 1 furlong equals 220 yards. Then I need to figure out how many yards are in a kilometer. So I will go back to Google. And you don't have to know this, and just about almost always, if you need to know an equation, I will give it to you. So 1 kilometer, and Google is a good resource, in yards. It turns out that 1 Google is equal to 1093.61 yards. I'm going to write that down. It's part of my notes as well. 1 kilometer equals that. With that information, I can write an equation to do this. I'm not going to show you all the math for it. But furlongs equals kilometers times 1093.61 divided by 220. Just take it on faith. I'm not going to show you the mathematical transformation, right? That could be my step for then a miracle occurs. I'm just going to copy that, right? I mean, I could type it again, right? Set furlong equals to kilometers times 1093.61 divided by 220, and then output furlongs. The set command, I think the book uses that. It just says that we're going to create a variable. Our language doesn't have a set command. So once you start turning this pseudocode into real code, you would leave off the word set. There's a lot of changes you would have to make to turn it into Python. This is not Python syntax to any degree at all. I'm just going to say that this is pseudocode for the problem. It's also an algorithm. This is a series of steps. It's the recipe for success. Now that I have all that stuff, I can write a program. I would need to know how to do output. I would need to know how to do input. I would need to know how to do the conversion, and then I would need to know how to do output. We could do that. Let's lecture a little more. Let's see if we can get done with chapter 1. Does that make sense though? The pseudocode for the problem outlines the logic, the so-called the algorithm, which is the recipe for solving the problem. Every time you open up the Betty Crocker book and learn how to bake a cake, you're seeing the algorithm for a cake. Pseudocode is written in English. It's a loosey-goosey specification of the logic. It is not a programming language. You could give this pseudocode to anybody who's a programmer and they could make it into the language of choice. If they're a C++ programmer, they would turn that into C++. If they're a Java programmer, so on. So it's not a programming language, but a description of the steps to take of the algorithm, the logic it has to follow. A programmer will then take that pseudocode and turn it into Python or whatever. Apparently I can't spell. Let's come back up here and fix that. Now there are rules for pseudocode. Even though it's loosey-goosey, there are rules. We will, when we hit it in the book. I like to mention things twice. I like to give you a sneak preview of what's coming up. Then I like for you to see it in the book. And then 3 times. And then we do it again in class, right? And by the 3rd time we've done it, it's well burned into your brain. Desk checking. Walking through a program's logic on paper before you actually write the program. What I ought to do is I ought to show my pseudocode to somebody else who understands the problem. I ought to take it, over to Michael or Lindy and say, check this out. Does this look like it's going to work? That's called a review. But they gave it a cute term of desk checking. Whatever. You're just stepping through the logic with somebody and everybody agrees, yeah, that's pretty cool. And believe it or not, there are some companies that hire 2 programmers to sit at the same computer and they trade off typing responsibilities.
So that's like proofreading?
Kind of like proofreading, except you have both people there. But yeah, each of you is proofreading what the other one's doing. Exactly. And the reason you do that is because you have 2 eyeballs on the screen. Your code is going to be twice as good or more. It, eliminates a lot of the problems. Cost twice as much. You're hiring 2 people to look at the same screen. And honestly, I would absolutely hate that. Who knows? Maybe I might like it. Maybe I might like my buddy. You never know. I think I would absolutely hate that. I probably would not want to work at a place like that. Alright, so there are hundreds of programming languages available. You would choose based on the features. Well, do I want this program to run really fast on Windows? Do I want it to run on a lot of computers? Not just Windows computers. I want to write it for my Mac as well. You would choose, in that case, a language that is cross-platform, like Python. Coding is easier than the planning step. Now that I've got those steps written down, it'd be pretty easy for me to do them, or to hand you the logic and you do them. Experienced programmers could successfully combine logic planning and program coding in one step. Yeah, I probably could have sat down and typed out this program. You've seen me sit down and just start writing. That's not a real strong recipe for success at the beginning of this unless the problem is really so easy and you really think you understand it. You ought to do a little bit of of planning, even if it's just writing, 4 big steps. This is all rigorous, right? This looks like it's following a specific syntax and stuff like that. I could have just written it like this. Ask the user how many kilometers, and then convert to furlongs using the formula shown in the specs, and then display the results. If you had that written down, it'd be a good way towards being able to solve the problem. But you might not just be able to sit down and type in all the code without having written that. I won't always make you do pseudocode, but at a certain point in the beginning of the class, coming up not too far from now, we'll be asking you to do stuff like this. And then you don't have the satisfaction of running it in idle, right? It's kind of a drag. And people who've done programming before want to actually write the code first and then create the pseudocode from it, or write the code first and then create the flowchart from it. That's cheating. I've done it, right? I did it in my high school programming class. I hated drawing flowcharts, so I'd write the program and then, anyways, I get it. Yeah, flowcharting will annoy some of y'all, and then we're not going to spend the whole time on flowcharts, but y'all got to get good at it for the, couple of weeks that we mention it. I shouldn't down talk them. Flowcharts are the most fun thing you'll ever do. You're going to like your flowcharts so much you will hang them on the fridge and mail them to all your friends. Okay, are we psyched up? No, that's not true. All right. We talked about the program that translates it into machine code, right? We've talked about when you click the run button, it turns into machine code. Feel free to say, no, we haven't talked about that. Give me some sanity checks. Lindy, have we talked about that? Is that sounding familiar? Okay, okay. So, yeah, I was pretty sure we had talked about it. Normally, I mean not normally, sometimes you write code, you compile it, it turns it into an exe, you give the exe to somebody else, and then you run the exe. That's not Python. Python is an interpreted language. You write the code, you run the program, you run the code, it gets interpreted into machine code, machine language, on the fly, line by line. Hope you understand what I mean by on the fly. You don't get an executable out of it. You can't send the executable to somebody else and run it. You have to give them the code. And so what is compiling? That's turning into machine language. What is machine language? It's just the stuff that draws the pictures on the screen. It's a series of opcodes. I said it. I am really being forgetful. My guess is I've not gone up here and drawn a picture about a dude named Chip. Is that correct? No Chip? We haven't done that?
No.
All right, we're going to do that. How a computer works. After this, we're going to be electronic engineers and we'll be able to make a maybe that's an exaggeration. But I'm going to talk about the way processors work from a very, very simplified level. And those of y'all who do have electrical engineering experience are free to laugh and mock me. Just don't do it too loud or distract me. We need to turn up the lights. We can't talk about this too long because I really, really want to give you all homework. We only have 20 minutes left. I probably ought to be saving this for another lecture, but I'm going to go forward anyways. It's the right time to talk about it. So, we got a dude named Chip. We're pretty mean. We locked him in a box. He's happy with his lot in life. Okay, so Chip's got a hole in the box where he can write on a scroll of paper, parchment or whatever. It's infinitely long, or it's not infinitely long, but it's, if you have a 4 gigabyte computer, it's 4 billion lines long. So he can write numbers on it. That's all he can write on it.
You may ask, well, what if he needs to write letters? Well, the letters get turned into numbers so that he can write them. So he's going to write some numbers here. Let's just say that our data is already loaded. I'm going to number these. Computers always start with 0 rather than 1, and that's why I made our homework assignment 0, just to kind of burn that in. All right, now we have some numbers. We're going to just put some numbers in, like the file was saved, and we had a number 3 there, and we had a 41 there. Well, it looks like a 9, so why not make it a 91? And 80, and there was a 77 there, and there was a 2 there, and there was a 4 there, right? There's a 0 there, and a 1 there, and a 2. Okay, so we have some data that he's going to be processing. But he doesn't know what to do, and we don't know how to tell him what to do. So we're going to make up a language for him. It's going to be called opcodes, because operation, we're going to give him a series of operations. We're going to say that the first opcode, the first kind of instruction he knows how to do, is to read from his parchment. The second thing he needs to be able to do is to write to the parchment. Then he needs to be able to add. We've got to make up something a little bit more than that. When he reads, what is he going to read to? Well, he has a really bad memory. So he's going to keep what's known as a register here that he can write into. We're going to call that register 1 and register 2. Or why did I say 1? Register A, register B, and register C. He's got 3 places he can write to. So the syntax that he has to obey is we're going to read from a specific address, which is one of these numbers, into a specific register. That's the syntax that we have to tell him. And then when we write, we're going to write to a specific address from a specific register, right? Our registers are A, B, and C, and our addresses are 1 through whatever. And when we add, we're going to say add from that register to that register and store the results in that register. Now for him to do the task that I want, which is just to add 2 numbers together and then write it back out, these are enough opcodes. Modern processors have like hundreds and hundreds of opcodes because they do all sorts of complicated things. All right, we're going to write a program. All right, Chip, here's what I want you to do. And I'm actually going to use read, write, and add rather than just write 1, 2, and 3. Right? So read from address 4 into register A. Right, I'm going to remove the R. All right, read from 4 into A. And then we're going to read from 2 and store it into B. And then we're going to add register A, register B, and store the results in C. And then we're going to write register C back out to another address. I don't care which one. Except I said that the syntax had to be the address first and then the register. That means we would get a syntax error. So write out the address A, the contents of C. This is what's known really as assembly. Assembly is when you have a written description of the opcodes that it can follow. And usually it's just a word and address and a word and an address. The lowest level programming language. But when you ran the assembler and would turn these all into the 0s and 1s that the computer actually understands. I'm going to skip that. Okay, now I'm going to run the program. Read 4 into A. Well, what's the number at 4? It's a 2. But it was the on the front of the row. Read address 2 into B. What's the address, the value of 2? Somebody in the front tell me. Yeah, if you can see it, what's at 2 is 80. All right, next step. Add A and B and store in C. 2 plus 80 is 82. And then write what is in C out to address A. And so he reaches way down here, or he scrolls the paper, or whatever, and puts an 82 there. And we could do all sorts of math like that. We might want to give him some other instructions, right? Like subtract, things like that. And it'd be real nice if he could write to a disk drive, because since this is RAM, as soon as we turned it off, all of our data is gone. But that's Chip. I hope that was as fun for you. Are there any questions with this? This is a series of opcodes. every chip has a list of opcodes that program it. Nowadays, chips have billions of transistors and they have hundreds of, thousands of opcodes that control them. This is a symbol. If I go over, well, I don't have the screen on yet. That makes sense?
No.
Wave two hands if you totally dig it. One hand if you kind of dig it. Thumbs down if you hate it. I'll have to do another lecture for the thumbs down. Yeah, okay. I'm making silly comments when I say hate it. Yeah, so I'm going to have to go over that again. Maybe do a separate lecture on it and record the lecture or something. But I hope we at least got the idea. We have a series of commands. Our programming language has to be turned into those series of commands. When we hit the run button in Python, it picks up a line of code and it turns it into a series of commands. Now that one command may be 1,000 or 10,000 opcodes long, right? Because this stuff's complicated. Not complicated to us, we just put a print command, but it's complicated to the computer. It's got to put some data here, it's got to put some data here, it's got to contact Windows. Windows has to know where to put it on the screen. Right. We don't want to have to write all that out. We just want to write a line of code, and then when we click the run button, it turns it into all the machine language, all those opcodes on the fly. All right, if I'm going to succeed in giving you any homework at all, we need to talk about doing math assignments, mathematical expressions. This is going to be very, very short. The homework's going to be very, very easy, but I don't want you all to go a week without, no homework. So I'm going to go back into idle, and I'm going to write a sample little program. And it's just going to calculate the area of a rectangle. What two pieces of information do you have to know to calculate the area of a rectangle? I think I heard some murmurs. Say it loud. Say it proud. Yeah, you have to know the length and the width, or the height and the width, whatever you want to call it. So we need to get some data in. We need to tell the user what to type. So print, what is the length? Or I'm going to shorten that because we're short for time. Length, question mark, end quote, parentheses. A print statement just tells the user. It displays a message on the screen. It doesn't let them type in anything. Now I'm going to use capital letters even though I don't normally like to, because the lowercase l looks like a 1. L stands for length in this case. I should actually type out the whole word, but we're saving time. L is equal to parentheses, in parentheses. The space is not necessary. Now let's get the width. Same deal. Print width, question mark. Print, parentheses, quote, width, question mark, end quote, in parentheses. Then it's going to be W equals input. W equals input, parentheses, in parentheses. Now we have all the data. I wish I had just done the coding for that pseudocode that I had done, right? The furlongs and the meters. But this is closer to what I really want you to do as homework, so we'll stick with that. Do you have to put all these blank lines? No. All right, so area. Why not go with the uppercase letter? No. I'm going to start doing it right. Lowercase letters, area, equals width times length. Then we need to tell the user, otherwise why did they type this stuff in? So we're going to put one more print command in. Print, parentheses, quote, area is, end quote, comma. And you might say, well, you made that lowercase a and this uppercase a. That's okay, because this message is just, it's just text, right? I might do area, whatever, how you say it in French or something like that. So area is, end quote, comma, and now we have to have the variable name perfect. It has to match case and everything. And that's our program.
Now that I've typed this, I'm going to remove a couple spaces to make it look a little bit better. I'm going to take, returns out. I'm going to take that one out. I'm going to take that one out. I'm going to leave those separated. You got to keep them separated. Alrighty, so there we have a little program, and I want to test it.
You don't have to indent.
No indentation because I never had a DEF statement, and I don't have any colons. If I was going to do that, but I'm not. Anytime you have a colon on a line above it, the next line has to be indented, but we only do colons if we have loops or if statements or DEFs. So save as CIT. This is just going to be lecture B math. Lecture B, excuse me, we're on lecture C. Lecture C math to separate it from our turtle program. Now I'm going to run it. Ask me for the link. My rectangle is 100. How wide is it? It's a skinny rectangle. 10. And it blew up. Yeah, that was my mistake, and I didn't mean to make that mistake. I apologize. Apologize very much. The problem is whatever they type in as a string, right? They could have typed in their name, right? We could have typed in Fred and Wilma there, and then when it got to here, you can't multiply strings. Can't multiply by Fred or Wilma, even if they typed in numbers, right? You can't multiply quote 1 end quote times quote 2. It has to be pure numbers. So I'm going to convert these numbers, these strings, into numbers. So underneath L equals input, I'm going to do L equals float parentheses L end parentheses. I'm going to do the same thing after W. W equals float parentheses W. W equals float parentheses caps W in parentheses, like that. This is how you get data from a user if it's numeric data. You tell them what to type, you give them an input statement, and then you do that. You can actually do that in one line of code, but I'm not going to tell you that this time. So we're getting 2 pieces of information. Now it ought to work. And if you didn't get it all typed in, that's okay. I'm going to end the lecture real soon and upload the notes and stuff like that. And I can also spend time getting y'all helped. Okay, so 100 times 10 actually is 1,000. So the program is working now. We could break it, right? If I type in something that's not allowed, you know, when it tries to turn it into a floating point number, what if I type in something bad, like 12? It doesn't know what that is. It can't do that. So we get a string from an input statement, and then we convert that string to a numeric data type with the float command. Turns it into a floating point piece of data. Floating point meaning there's a decimal point in it. They don't have to type a decimal, but if there is, it'll take it into account. All right, our homework is going to be based on this idea, and it's going to be due a week from today, so it's not like, you know, you have to do it tonight. So if you didn't get all this, that's okay. We can talk more on Thursday. Homework. Write a program that will ask the user for the value of X and the value of Y. Then have the program calculate the following values. X times Y, you know what that means. It means multiply, right? It's childish, but go by it. X divided by Y, X plus Y, and X minus Y. Printing out the results each time. That's your homework assignment. And there's like, I could think of like 4 different ways of structuring this. But you get the idea. This is real similar to this one. You're going to ask for X, you're going to ask for Y, you're going to perform a calculation, and you're going to print it. but then you just have another one. Don't ask for X and Y every single time, right? Once you get X and Y, you don't need to ask them again. You're just going to do all this math. So I will upload that into a homework document for y'all. Are there any questions over that? Does that make sense? If it doesn't make sense, contact me about it and I will explain further. If it doesn't make sense, ask me questions about it on Thursday. So don't put off writing this until Monday night next week. I mean, you don't have to do the whole thing tomorrow, but right? Pardon?
You want us to print the code like after it's run? You want us to print it and like turn it into you?
No, you're going to upload it into the homework folder.
Okay.
Right. Yeah, you don't have to print the code. When I say print the results, I mean print what x, y times y is. So how about printing the results of the math each time? All right, I'm going to make a Dropbox so that people can upload stuff. And if you want to hang out and finish typing this code that was up here, that's totally cool as well, but I got to get the Dropbox made first. That's in the wrong place. So homework 1 is input and math, right? Because we're using the input statements and we're doing some math on them. And it'll be due Monday night with a day's grace period. I have office hours right before this class, so if you ever want to hit me up before class starts, feel free.